practice a stoichiometry problem. First, this problem asks us to balance the following equation. We're going from KNO3 to KNO2 plus O2. The best place to start is to take account of how many atoms of each element we have present on the products and reactant side of the equation. So on the left side of our equation, we have 1K, 1N, and 3O. And on the product side, we have 1K, 1N, and 4O. So here the best place to start is to give ourselves 2 moles of KNO3 because that's the only way we're going to increase anything on our reactant side of the equation. So now we have 2 potassium, 2 nitrogen, and 6 oxygen. Now we know that we need to increase our potassium and nitrogen, so we know at the very least we'll need a coefficient of 2 in front of KNO2. And now we'll have 2K, 2N, and then we have 4 oxygens from the KNO2 and 2 oxygens from the O2, and that leads us to 6. So our equation is now balanced and we can move forward with our calculation. This problem asks, how many moles of KNO2 are produced from 2.79 grams of KNO3? So we'll start with the value given in the problem, 2.79 grams of KNO3. Now we know we need to convert between grams and moles. And how do we do that? How do we go from grams to moles? We need the molar mass from the periodic table. So let's calculate that. To find the molar mass of KNO3, we'll get our values from the periodic table and add them together. We know that potassium has a molar mass of 39.1 grams per mole. Nitrogen has a molar mass of around 14 grams per mole. And oxygen has a molar mass of approximately 16 grams per mole. And we'll multiply that by 3. If we add these values together, we'll get the molar mass to be 101.1 grams per mole, and we can add that to our calculation setup. Now we need to go from moles of KNO3 to moles of KNO2. This is called our mole ratio, and we can go and look at our equation and use our coefficients that we balance our equation to, and we know we're going from 2 moles of KNO3 to 2 moles of KNO2. And those are the units we want to end with, so we know we're at our final step. So if you grab your calculator and calculate out, you'll get 0.0276 moles of KNO2. And looking to our problem, we're starting with 3 significant figures, so we can report this to 3 significant figures as our final answer.